So if you watched movie 1, you'll know that after our initial experiments, we got to the point where we decided that trying to do a smart contract that would be a RDF query engine was going to be fairly impossible at the moment. So we'd focus instead on the data store. Now, after pushing the data as far as we could with that particular contract, we found that, as we predicted, the array size made it impossible to put data beyond about 9,000 records in, because the fee to add an individual structure to the bottom of the array became more expensive than the cost of a single transaction. So at this point, we completely redesigned the data store contract. So the first thing we did in the data store is get rid of the structure and get rid of the array completely, and replace them with a series of mappings. So everything was now stored in mappings and pulled out of mappings. And we found then that adding an extra item to the store made no incremental cost. Therefore, we could effectively add as much data as we liked. We then wanted to have some sort of front end to use with this data store, so we decided to extend the linked data fragment server front end and data store model. To this end, we created a new type of data store inside the linked data server code. And here you can see our first attempt, where we basically pull data out of the smart contract and then run the standard search on it. So here in the interface, you can see an awful lot of our experiments, but these were the early ones. So we started with small data sets, 20,000, 40,000, 60,000, and up to 100,000. So let's look at one of these. So here, this is actually all being pulled out of our data store contract, which is now using mappings. And we can click about and search that just as you can with any other linked data fragment data set. So that worked really well. And so we put more and more records in. But what we found was, as the number of records increased, we hit a wall. And the wall seemed to be about 60,000 records. So if I try and go to the 100,000 record set like I have now, it just went off on one for ages. So we were hitting some problem where we didn't really understand what it was. Now the problem seemed to be with making a single call to the data store and expecting it to return an array of data that it pulled out of the mapping in one massive chunk. It seemed not to be able to handle anything over 60,000. So in the second iteration of our data store code in the LDF server, we identified this 60,000 record step. And what we did is we changed the code so that if it was greater than 60,000, it called them the array items one at a time so that it didn't fall over. So here in the interface, you can see that this is what we're calling optimized. So it was then able to get past 60,000 records, but it was very, very slow because it was calling each of the items one at a time. So this does eventually come back, but it's extremely slow. So basically looping through and calling each individual record of a large data set is just too slow to use practically. So we had to try and investigate how we could get around this problem. So we spent some time trying to understand why, if you make a transaction call to a contract that is a read-only transaction and therefore you don't have to set a gas cost, why it was failing. And what we found is that we didn't understand that even if you're just doing a read-only call, in the background a gas cost is being set, and we were exceeding that gas cost with returning 60,000 records. And what we could actually do is set a higher gas cost in our transaction call and basically get around the problem like that. So we did another round of experiments where we basically set the gas really, really high so that it could pull the data in one go, no problem. Now, oddly, in parallel, because there was two of us working on it, my colleague had tried a different approach, and he tried editing the data store contract to store the mappings in chunks of 60,000 so that a single pull would never exceed the basic gas cost. And what we found in the end when we compared the two, and I don't have the one in between in the interface, which is kind of annoying, it was actually faster to pull 2 calls to the data store for multiples of 60 or however many were required, rather than one big call for, say, 200,000. It was easier to make 4 calls for smaller amounts, increments of 60 or below. And because the chunking version was actually faster retrieving the data, we in the end discarded the original version and we stuck with the chunking version. So this is the third iteration of our data store contract in effect. We're now still using mappings. It's been optimized, but it's also been chunked. And now we have at the moment set a chunk size of 60,000 because with the data that we're storing, which is arrays of hashes of a fixed size, that was the amount where we hit the default getter limit for gas. Now, if you're using different sorts of data, I assume you can the boundary might be different. So it's a chunk limit which could be changed, but that's what it was for our particular RDF data store. So here we have a chunk limit, loads of various indexes to get at the data in different ways more quickly, and code that are basically chunks the data into mappings in chunks and gets it out again in chunks. So using this new data store contract, we weren't sure if there was a limit on how much data you could put in at all. Now we were chunking it in 60,000. So we ended up putting in 1,000,000 dbpedia records just to see if we could, and it seemed to work fine. Now pulling out 1,000,000 records is not super fast, but it's not ridiculously slow, and it's searchable. In reasonable times. So that's where we've got to at the moment. We have now got this data store contract chunking at 60,000 records, and we've put 1,000,000 records into it.